Hey everyone, Mr. Andrew here. Today, I'm going to be talking about naming ionic compounds. Okay, so previously we've talked about how ionic compounds are represented, and we've looked at both chemical formulas and also Lewis dot structures. But today we're looking at naming. How do we give these substances names? Now, we have to follow a specific set of rules for these names so that way when two people have a conversation about something and they say sodium chloride, for instance, both parties know exactly what they're talking about. And so thankfully ionic compounds have a pretty clear set of rules with some exceptions as far as how naming goes. So there are three rules to naming ionic compounds. Okay, so the first rule is the cation is always written first, followed by the anion. Now, there is, cations are positively charged and anions are negatively charged, and you can certainly figure that out by looking at the periodic table. But one strategy that I've found is effective for students when they're trying to identify the cation is whichever element is on the left side. So whichever element is written closer to the left side of the periodic table, that is the one that's going to be written first. Okay? And that's because cations tend to be on the left side of the periodic table. Now, for monoatomic cations, when we write it down, we just write the element name. Now, at this point in time, we're not really talking about anything but monoatomic cations. So basically, monoatomic just means it appears on the periodic table directly. So if it's on the periodic table and it's a cation, we just use the element name. So in my example right here, I have NaCl. Na is sodium. That's my cation. And you can see that sodium's part of the name. I just write the word sodium. Okay. Last rule, for monoatomic anions, use the root of the element name plus the suffix IDE. Now, this is kind of the trickiest part of this, of naming ionic compounds, and that's because there are some rules and they mostly work, but it's kind of a vibes-based thing. It's kind of a feel as far as like what feels right, okay? So, in my example, chlorine is my anion, okay? And so when I change it, I need to change the ending to IDE, okay? Now, the issue is not every element follows, the rules, or it's not always clear as far as how this is supposed to work. So, or it's kind of a feel thing. So, the best rule that I can give you is what I call the one syllable rule, okay? I might have misspelled syllable right there. It's been a while since I've written that word, so forgive my spelling if it's wrong. So here's what I mean. When you're changing the anion to the IDE form, you generally cut it off, or you switch it after the first syllable, usually right after the first syllable. So what I mean is chlorine, like you hear the emphasis for the syllables, chlorine, okay? You save the first syllable, the chlor part, but all the rest of it, you ignore that and you just add IDE at the end. So chlorine becomes chloride, okay? So you can see kind of the first syllable right here and then the IDE form after that, okay? Now, this is one of those skills where the best way to go about it is to just practice this and to learn it. So I'm going to do some examples of this, okay? So right here, I have a question that says, what is the name of an ionic compound formed between beryllium and fluorine? So I'm going to look at my periodic table. Okay. I've got beryllium right here, and I've got fluorine. Okay. So I need to figure out which order to write these in. I'm going to use my left side rule. So beryllium is closer to the left of the periodic table than fluorine. So I'm going to write beryllium first. And I'm going to write it just the exact same way it appears on the periodic table. So first part is beryllium. And then fluorine, that's my anion. So I have to change it to the IDE form. So fluorine, okay, you hear the two syllables right there? Fluorine becomes fluoride, okay? Okay, and that's all there is to it. The answer is beryllium fluoride. Okay, so again, the one syllable rule is kind of a feel thing, okay? And there are some exceptions to it, but it works most of the time, okay? All right. What is the proper name for an ionic compound formed between oxygen and aluminum? Okay. So let's clean this up. Okay. I have oxygen and aluminum. Now this one's a little tricky because it listed oxygen first, but oxygen is on the right side of the periodic table compared to aluminum. Aluminum's closer to the left. So as a result, aluminum is written first, and that's followed by oxygen. Oxygen becomes oxide. So even though oxygen has 3 syllables now instead of 2, oxygen, we still chop it off after the first syllable, oxide. Okay. This is my name for my ionic compound, aluminum oxide. Okay. Next one. What is the name for this ionic compound? Okay. Now this question's a little bit different because I got a formula this time instead of just a couple elements. Okay. Now this one is actually better in some ways than the other ones. They're a little bit easier to solve. Okay. But there is something different here. And what's different is this subscript, okay, this little 2 right here. Remember, the subscripts tell us how many copies of each element we've got. But the good news is, for ionic compounds, we can just ignore the subscripts completely, okay? And the reason for that is ionic compounds have to be balanced in terms of positive and negative charges. So what that means is, for these 2 elements, there's only one possible way that they can combine and end up neutrally charged overall. Rubidium has a +1 charge, sulfur has a -2 charge. So you have to have 2 rubidiums to cancel out the 1 sulfur. That combination of 2 rubidiums and 1 sulfur neutralizes it, and that's our formula. If we had, like, let's say 3 rubidiums and 1 sulfur, it wouldn't be charge balanced. So that's not an ionic compound. So when we're talking about ionic compounds, we can just ignore the subscripts because each of these names only has one possible combination that would be charge balanced. So the good news is, for any of these that you have a formula, the formulas have to be written in the correct order as well. So what that means is, whichever one is listed first in the formula, that's the one that gets named first also. So Rb is rubidium, and S is sulfur. So sulfur becomes sulfide. Okay, this is the name of the compound. All right, let's keep going. Okay, I'm going to start working a little bit faster here because I've explained several of them. Okay, so we have lithium and phosphorus. Okay, Lithium is listed over here. Phosphorus is over here. Okay, so you can see lithium is closer to the left side, so it's going to get written first. Okay, so this is going to become lithium, and phosphorus is going to be phosphide. So again, phosphorus has multiple syllables. It has 3 syllables, but we still cut it off right after the first syllable. So phosphorus becomes phosphide. Okay. Okay, magnesium and bromine. Magnesium's closer to the left, so that gets written first. And bromine becomes bromide. Okay, let's keep going. Oxygen and aluminum. That's aluminum oxide. Nitrogen and sodium. Sodium's on the left, so we're going to start with sodium. And then nitrogen becomes nitride. Okay, continuing on. Okay, SR3N2. SR is strontium. And N2, that's nitrogen. As we saw in the previous one, it's just nitride. Okay. Ga3S. Ga is gallium. And S is sulfur, which becomes sulfide.